7. Landforms and their evolution. Part 1. What are landforms and landscapes? Small to medium tracts or parcels of the Earth's surface are called landforms. Several landforms make up the landscapes. Each landform has its own physical shape, size, materials, and is a result of the action of certain geomorphic processes and agents. Every landform has a beginning. Landforms once formed may change in their shape, size, and nature slowly or fast due to continued action of geomorphic processes and agents. What are the important aspects of evolution of landforms? The evolutionary history of the continually changing surface of the Earth is essential to be understood in order to use it effectively without disturbing its balance and diminishing its potential for the future. Changes on the surface of the Earth owe mostly to erosion by various geomorphic agents. Of course, the process of deposition too, by covering the land surfaces and filling the basins, valleys or depressions, brings changes in the surface of the land. Deposition follows erosion and the depositional surfaces too are ultimately subjected to erosion. The geomorphic agents acting over long periods of time produce systematic changes leading to sequential development of landforms. Each geomorphic agent produces its own assemblage of landforms. Not only this, each geomorphic process and agent leave their distinct imprints on the landforms they produce. As the geomorphic agents are capable of erosion and deposition, two sets, that is erosional destructional and depositional constructional landforms, are produced by them. Many varieties of landforms develop by the action of each of the geomorphic agents depending upon especially the type and structure, that is folds, faults, joints, fractures, hardness and softness, permeability and impermeability, etc. There are some other independent controls like 1. Stability of sea level. 2. Tectonic stability of landmasses. 3. Climate, which influence the evolution of landforms. Landmasses created by running water. In humid regions, which receive heavy rainfall, running water is considered the most important of the geomorphic agents in bringing about the degradation of the land surface. There are two components of running water. One is overland flow on general land surface as a sheet. Another is linear flow as streams and rivers in valleys. Most of the erosional landforms made by running water are associated with vigorous and youthful rivers. Flowing over, but these phenomena will be on a small scale compared to those associated with rivers flowing over medium to gentle slopes. The gentler the river channels in gradient or slope, the greater is the deposition. When the stream beds turn gentler due to continued erosion, downward cutting becomes less dominant and lateral erosion of banks increases, and as a consequence the hills and valleys are reduced to plains. Overland flow causes sheet erosion. Depending upon irregularities of the land surface, the overland flow may concentrate into narrow to wide paths. Because of the shear friction of the column of flowing water, minor or major quantities of materials from the surface of the land are removed in the direction of flow and gradually small and narrow rills will form. These rills will gradually develop into long and wide gullies. The gullies will further deepen, widen, lengthen and unite to give rise to a network of valleys. In the early stages, downcutting dominates, during which irregularities such as waterfalls and cascades will be removed. In the middle stages, streams cut their beds slower, and lateral erosion of valley sides becomes severe. Gradually, the valley sides are reduced to lower and lower slopes. The divides between drainage basins are likewise lowered until they are almost completely flattened, leaving finally a lowland of faint relief with some low-resistant remnants called monadnocks standing out here and there. This type of plain forming as a result of stream erosion is called a penplain, an almost plain. The characteristics of each of the stages of landscapes developing in running water regimes may be summarized as follows. Youth. Streams are few during this stage with poor integration and flow over original slopes, showing shallow V-shaped valleys with no floodplains or with very narrow floodplains along trunk streams. Streams divides are broad and flat with marshes, swamp and lakes. Meanders, if present, develop over these broad upland surfaces. These meanders may eventually entrench themselves into the uplands. Waterfalls and rapids may exist where local hard rock bodies are exposed. Be mature. During this stage, streams are plenty with good integration. The valleys are still V-shaped but deep. Trunk streams are broad enough to have wider floodplains within which streams may flow in meanders confined within the valley. The flat and broad interstream areas and swamps and marshes of youth disappear and the stream divides turn sharp. Waterfalls and rapids disappear. C. Old. Smaller tributaries during old age are few with gentle gradients. Streams meander freely over vast floodplains showing natural levees, oxbow lakes, etc. Divides are broad and flat with lakes, swamps and marshes. Most of the landscape is at or slightly above sea level. Erosional landforms. 1. Valleys. Valleys start as small and narrow rills. The rills will gradually develop into long and wide gullies. The gullies will further deepen, widen and lengthen to give rise to valleys. Depending upon dimensions and shape, many types of valleys like V-shaped valley, gorge, canyon, etc. can be recognized. A gorge is a deep valley with very steep to straight sides, and a canyon is characterized by steep step-like side slopes and may be as deep as a gorge. A gorge is almost equal in width at its top as well as its bottom. In contrast, a canyon is wider at its top than at its bottom. In fact, a canyon is a variant of gorge. Valley types depend upon the type and structure of rocks in which they form. For example, canyons commonly form in horizontal bedded sedimentary rocks and gorges form in hard rocks. 2. Potholes and plunge pools. Over the rocky beds of hill streams, more or less circular depressions called potholes form because of stream erosion aided by the abrasion of rock fragments. Once a small and shallow depression forms, pebbles and boulders get collected in those depressions and get rotated by flowing water, and consequently the depressions grow in dimensions. A series of such depressions eventually join and the stream valley gets deepened. At the foot of waterfalls also, large potholes, quite deep and wide, form because of the sheer impact of water and rotation of boulders. Such large and deep holes at the base of waterfalls are called plunge pools. These pools also help in the deepening of valleys. Waterfalls are also transitory like any other landform and will recede gradually and bring the floor of the valley above waterfalls to the level below. 3. Incised or entrenched meanders. In streams that flow rapidly over steep gradients, normally erosion is concentrated on the bottom of the stream channel. Also, in the case of steep gradient streams, lateral erosion on the sides of the valleys is not much when compared to the streams flowing on low and gentle slopes. Because of active lateral erosion, streams flowing over gentle slopes develop sinuous or meandering courses. It is common to find meandering courses over floodplains and deltaplains where stream gradients are very gentle. But very deep and wide meanders can also be found cut in hard rocks. Such meanders are called incised or entrenched meanders. Meander loops develop over original gentle surfaces in the initial stages of development of streams, and the same loops get entrenched into the rocks normally due to erosion or slow, continued uplift of the land over which they start. They widen and deepen over time and can be found as deep gorges and canyons in hard rock areas. They give an indication on the status of original land surfaces over which streams have developed. 4. River terraces. River terraces are surfaces marking old valley floor or floodplain levels. They may be bedrock surfaces without any alluvial cover or alluvial terraces consisting of stream deposits. River terraces are basically products of erosion as they result due to vertical erosion by the stream into its own depositional floodplain. There can be a number of such terraces at different heights indicating former riverbed levels. The river terraces may occur at the same elevation on either side of the rivers, in which case they are called bed terraces. When a terrace is present only on one side of the stream and with none on the other side, or one at quite a different elevation on the other side, the terraces are called unpaired terraces. Unpaired terraces are typical in areas of slow uplift of land or where the water column changes are not uniform along both the banks. The terraces may result due to receding water after a peak flow, change in hydrological regime due to climatic changes, tectonic uplift of land, sea level changes in case of rivers closer to the sea. Depositional landforms. 1. Alluvial fans. Alluvial fans are formed when streams flowing from higher levels break into foot slope plains of low gradient. Normally very coarse load is carried by streams flowing over mountain slopes. This load becomes too heavy for the streams to be carried over gentler gradients, and gets dumped and spread as a broad low to high cone-shaped deposit called alluvial fan. Usually, the streams which flow over fans are not confined to their original channels for long, and shift their position across the fan, forming many channels called distributaries. Alluvial different location. The load carried by the rivers is dumped and spread into the sea. If this load is not carried away far into the sea or distributed along the coast, it spreads and accumulates as a low cone. Unlike in alluvial fans, the deposits making up deltas are very well sorted with clear stratification. The coarsest materials settle out first and the finer fractions like silts and clays are carried out into the sea. As the delta grows, the river distributaries continue to increase in length and delta continues to build up into the sea. 3. Floodplains. Deposition develops a floodplain just as erosion makes valleys. Floodplain is a major landform of river deposition. Large-sized materials are deposited first when stream channel breaks into a gentle slope. Thus, normally, fine-sized materials like sand, silt and clay are carried by relatively slow-moving waters, in gentler channels usually found in the plains, and deposited over the bed and when the waters spill over the banks during flooding above the bed. A riverbed made of river deposits is the active floodplain. The floodplain above the bank is inactive floodplain. Inactive floodplain above the banks basically contain two types of deposits: flood deposits and channel deposits. In plains, channels shift laterally and change their courses, occasionally leaving cut-off courses which get filled up gradually. Such areas over floodplains built up by abandoned or cut-off channels contain coarse deposits. The flood deposits of spilled waters carry relatively finer materials like silt and clay. The floodplains in a delta are called delta plains. Natural levees. These are always found associated with floodplains. Natural levees are found along the banks of large rivers. They are low, linear and parallel ridges of coarse deposits along the banks of rivers, quite often cut into individual mounds. During flooding, as the water spills over the bank, the velocity of the water comes down and large-sized and high specific gravity materials get dumped in the immediate vicinity of the bank as ridges. They are high nearer the banks and slope gently away from the river. The levee deposits are coarser than the deposits spread by floodwaters away from the river. When rivers shift laterally, a series of natural levees can form. Point bars. These are always found associated with floodplains. Point bars are also known as meander bars. They are found on the convex side of meanders of large rivers and are sediments deposited in a linear fashion by flowing waters along the bank. They are almost uniform in profile and in width and contain mixed sizes of sediments. If there are more than one ridge, narrow and elongated depressions are found in between the point bars. Rivers build a series of them depending upon the water flow and supply of sediment. As the rivers build the point bars on the convex side, the bank on the concave side will erode actively. 4. Meanders. In large flood and delta plains, rivers rarely flow in straight courses. Loop-like channel patterns called meanders develop over flood and delta plains. Meander is not a landform but is only a type of channel pattern. This is because of propensity of water flowing over very gentle gradients to work laterally on the banks. Unconsolidated nature of alluvial deposits making up the banks with many irregularities, which can be used by water exerting pressure laterally. Coriolis force acting on the fluid water deflecting it like it deflects the wind. When the gradient of the channel becomes extremely low, water flows leisurely and starts working laterally. Slight irregularities along the banks slowly get transformed into a small curvature in the banks. The curvature deepens due to deposition on the inside of the curve and erosion along the bank on the outside. If there is no deposition and no erosion or undercutting, the tendency to meander is reduced. Normally, in meanders of large rivers, There is active deposition along the convex bank and undercutting along the concave bank. The concave bank is known as cut-off bank, which shows up as a steep scarp, and the convex bank presents long, gentle profile and is known as slip-off bank. As meanders grow into deep loops, the same may get cut off due to erosion at the inflection points and are left as oxbow lakes. 5. Braided channels. When rivers carry coarse material, there can be selective deposition of coarser materials, causing formation of a central bar which diverts the flow towards the banks, and this flow increases lateral erosion on the banks. As the valley widens, the water column is reduced and more materials get deposited as islands and lateral bars, developing a number of separate channels of water flow. Deposition and lateral erosion of banks are essential for the formation of braided pattern. Or, alternatively, when discharge is less and load is more in the valley, channel bars and islands of sand, gravel, and pebbles develop on the floor of the channel, and the water flow is divided into multiple threads. These thread-like streams of water rejoin and subdivide repeatedly to give a typical braided pattern.